Hello everyone, for this tutorial video I like to explain how resistance changes with temperature, which is more complicated than the simple dependence of resistance with relation to the dimensions of the wire. In particular, as a general rule and an exact formula, the hotter the wire, the greater the resistance. Although if you wanted a more exact formula for it, you could state that the resistance for a given temperature equals the resistance at a reference temperature, typically 20 degrees Celsius or sometimes 0 degrees Celsius, times 1 plus the temperature coefficient of resistance times the change in temperature, measured from the temperature of the resistance you want to find to the temperature of the reference resistance. The temperature coefficient is the messy part of the formula, because there's no neat way to know exactly the number ahead of time. It has to be measured on a case-by-case basis. But as a general rule, the better something conducts heat, the more resistance it will generate in comparison to the reference resistance, which should make intuitive sense from the formula provided. For this reason, objects of absolute zero temperature, or temperatures of 0 degrees Kelvin, are called superconductors because of the fact literally no resistance is generated at that particular temperature. Although this may seem like something that is 100% beneficial with no drawbacks whatsoever, there is a problem if you stop to think about it. Because we know if there's no resistance, the circuit is called a short circuit. So a circuit made out of only superconducting materials would most likely go haywire from the excessive current. Now I've explained the other important detail of how resistance works in wires, which is dependence of resistance on temperature. I can begin explaining more sophisticated components than simple resistors or batteries, starting with capacitors in the next video. Don't forget to subscribe if you found this video informative, and make sure to see other tutorial videos, and follow me on either Facebook or Twitter for more content.